I show the MyJVN Product Dictionary challenge for collaboration with the vulnerability database and asset management. As the cyber attacks become more sophisticated, information systems are becoming more serious for the threats. To prevent damage from cyber attacks, it is necessary to respond quickly to the vulnerability that are disclosed. This presentation, the concept of MyJVN Product Dictionary that supports collaboration between the vulnerability database and asset management in order to construct an environment and enable rapid response to the cyber attacks. First of all, I'm explaining the Japan vulnerability notes, a feature comprehensive and widely utilization public vulnerability database operated by IPA and JPCERT in Japan. JVN included the JVN, JVN IPA, and MyJVN. In 2002, I initiated the development of research sites that laid the foundation for what eventually becomes JVN. 2008, I had launched the MyJVN, a security automation platform. Currently, I'm taking lead in development extension for the MyJVN, enhancing its capability and the features. This presentation aims to provide insight into the importance and the impact of MyJVN as a critical resource in the field of vulnerability management, in its evolution and ongoing development. Here, in focus on the future of Japan vulnerability note system. JVN is a comprehensive platform composed of the three key components: JVN, JVN IPA, and MyJVN. JVN and JVN IPA served as a centralized vulnerability database, gathering information from various sources, Japan and of course CSAT community and National Vulnerability Database. It provides a comprehensive view of vulnerability countermeasure information. MyJVN is an essential tool for security automation and vulnerability management. It enables users to efficiently track and manage vulnerability within the systems, providing timely alert and updates. This presentation focuses on MyJVN. MyJVN is seamlessly integrated with the CPE database, enabling efficient collaboration with the filtered security information and version checker. With MyJVN, a machine-readable interface, user can easily retrieve and process security information, filtering it based on the specific needs. The integration with the CPE database allows the precise identification and classification of software products, enhancing the accuracy and reference of the security information. Additionally, MyJVN version checker checking feature ensures the user stays informed about the latest version and the patch available for their software. By leaving the CP and overall database, MyJVN enables automated version comprehension and alerts users to any vulnerability update and associated with their installed software version. The primary motivation behind this initiative to foster collaboration between the vulnerability database and the asset management system through the utilization of software product identification. Our main objective is to tackle the challenge associated with the software product identification in three key areas. One is the software lifecycle. We aim to improve the identification of software product throughout the lifecycle, from the initial development stage to the release and beyond. Second is SBOM. Creation of the comprehensive and associated SBOM are crucial for the effective software management. Number 3 is the vulnerability alert. Rapid and accurate identification of the software products is vital for the efficient vulnerability management. By addressing these aspects of the software product identification, we strive to the enhance and the overall effective and efficiency of software management and security practice. Through collaboration and innovation, we aim to create a more robust and secure software ecosystem. First, focus on the challenge related to software product identification in a software lifecycle. It highlights the key issues identified during the SCAP V2 April Developer Day 2019 presentation. One of the primary challenges is accurate identification of the specific software release and its corresponding build information. This includes capturing and tracking essential details such as version number, build date, and other relevant metadata. Another challenge is the identification of applicable patch for the specific software release. It is crucial to have a reliable mechanism to associate patches with their respective software version, ensuring the corresponding patch and apply to address vulnerability to or enhance functionality. Ideally, software should be identified during the build process, and identification information should be released together with the software. SCAP V2 April Developer Day 2019 present several key highlights we discussed, shedding light the process of software identification using a CP name. Let's explore these highlights. Firstly, it is not approximately 5% of CP name are provided by software providers around the time of the software release. The name serves a unique identifier for the software products and version. On the other hand, the measure of CP names around 5% are created by analysis phase, National Vulnerability Database during the managed phase. Its creation takes place during the vulnerability analysis process. Analysts identify software components associated with the vulnerability discovered in the software. However, it is important to recognize the software identification occurring after vulnerability is discovered deemed too late. In the context of creating software bill of materials, there is several challenges related to the software product identification. One of the main issues is the presence of the various ID specifications, including CPE, package URL, SWHID, and suite. There is a specification of a different approach for the unique identify software products and their components. Another specification issue in software product identification for SBOM is a variation in the combination of software product identification and primary formats. This variety adds another layer of complexity to the already challenged identification process. Different PIDs such as CPE, SWHID, suite, package URL may be utilized, and each may have their own primary formats. In the context of vulnerability alert, there are several issues related to software product identification that need to be addressed. One of these issued in the matching process between vulnerability information, reference, and installed software. To illustrate this, we have included a diagram that showcases the flow of information and challenge encouraged during the matching process. The diagram visually represents the complexity involved in accurately identifying the software affected by vulnerability and ensuring the appropriate remediation measure undertaken. By understanding and addressing this issue, we can improve the accuracy and efficientness of vulnerability alert system, ultimately enhancing our availability, mitigate risk, and protect against the potential security threats. In the context of vulnerability alerts, there is a specific challenge associated with the software product identification that needs to address. One of these challenges is a matching process between vulnerability information and the installed software, which relied on the product dictionary as a reference. However, this approach faced certain issues that required resolution. Firstly, there are variations in notation between the CP and the product names, which can lead to the inconsistency and difficulty in accurately identifying the corresponding software products. Secondly, variance in version notation further complete the matching process. Different software versions may have distinct versioning formats, making it challenging to accurately match the installed software version with vulnerability information. When it comes to a software product identification scheme, there are specific requirements that need to be met concerning current state of product identification. These requirements aim to enhance efficiency and effectivity of the identification process. The following three requirements are essential. Number one is the associated product for the PID to products that are not yet assigned PID. It is critical to establish a systematic procedure for addressing PIDs to products that currently does not have an identifier. Number two is a PID dissemination procedure for the product that have assigned PID. Once a product has assigned a PID, it is also essential to have a clear dissemination procedure in place. Number three, minimizing identification spelling variations. Consistency in the identification spelling is vital to avoid confusion and improve the accuracy of software product identification. For our first proposal in the presentation, we present a software product identification scheme aimed to enhancing collaboration between the vulnerability database and asset management system. The key objective of this scheme is to establish standardized and efficient method for identifying software products. Here are main components of the proposed scheme. A software product identification scheme provides vendors registered product identifiers to the MyJVN Product Dictionary. PID serves as a unique identifier for each software product. The same PID is provided to the both installed software and corresponding data in the vulnerability database. This is presentation. We introduced the concept of the software product identification scheme, highlighted the importance in the achieve effective matching and providing a vulnerability alerts. The scheme aims to establish a standardization and effective method to identifying software and software products, enabling seamless collaboration between the different stakeholders. Here are the key points regarding the software product identification scheme. MyJVN Dictionary construction. The MyJVN Product Dictionary serves as a centralized repository for the software product information. It contains a comprehensive collection of the product identifiers assigned to each software product. Matching and providing vulnerability alerts. A software product identification scheme ensures accurate matching of the vulnerability information and installed software. By referencing the MyJVN Product Dictionary, the scheme provides a reliable and timely vulnerability alerts. For our second proposal, we focus on the key feature of MyJVN Product Dictionary entry, which are the follows: comprehensive PID association. The MyJVN Product Dictionary entry facilitates the association of multiple PIDs, include the CPE, package URL, SWHID, hash, and the software ID tag suite. By incorporating various identifiers, we aim to establish a more robust and flexible identification scheme, identification framework. Provision of identifiers. Our scheme addresses the issue of product lacking PID by proposing systematic procedure for associated identifiers. Number 3 is the global collaboration. With assigned PID, our schema promoted global collaboration aiming stakeholders, fostering a cohesive and cooperative environment. The figure visually represents the MyJVN Product Dictionary entry, providing essential information about vendor and products. The entry including the following details: MyJVN product ID, product name, CP, NVD ID, version, vendor PID, SPDX ID, package URL, and the hash. By incorporating these elements into the MyJVN Product Dictionary, we established a comprehensive and standardized repository of software product information. Each comprehensive serves a specific purpose in facility accurate identification and efficient collaboration between stakeholders. The MyJVN product ID serves a unique identifier within the dictionary, enabling easy referencing and cross-reference of the products. The product name provides a clear and recognized label for each software product. Overall, the inclusion of these elements in MyJVN Product Dictionary entry enhances the software product identification, fosters collaboration, and promoted effective vulnerability and management. This figure illustrates the format scheme of MyJVN Product Dictionary entry, encompassing crucial information about the vendors and products. The entry adopts the MyJVN product ID as a certain identifier, facilitating the association of multiple PIDs for enhancing software product identification. Within the identification, This figure illustrated the example for the MyJVN Product Dictionary as entry. showcasing the practical implementation of a proposal software product identification scheme. The example MyJVN Product Dictionary entry includes essential information such as the vendor and product details utilizing proposed identification scheme. In our third proposal, we introduce the feature of called MyJVN Product ID, JVN PID within the software product identification scheme. This feature aims to further improve the efficiency and compatibility of product identification, specifically within the MyJVN Product Dictionary. The key feature of MyJVN Product ID, JVN are the following: administrator PID. MyJVN Product ID serves an administrative identifier within the MyJVN Product Dictionary. Secondly, the compatibility with CP. The MyJVN Product ID, JVN PID is designed to be compatible with the CP standard. Number three, the enhanced version stylizing. The MyJVN Product ID introduces a standardized version styling format, which fixes the version format at 5 digits. This format is specified tailored to the facility, easy to the accurate version comparison. This is provide an overview of the format, a present sample of MyJVN Product ID, JVN PID. MyJVN PID MyJVN Product PID follows a specific format that including various fields represent specific information about the software product. The example of the illustrating structure of specifying the affected product versioning using JVN PID. In this example, we specified the affected product version for the specific MyJVN product ID, which is JVN PID 1.0 system BOM. The associated CP identifier for the product is CP 2.3 system BOM and BOM. The version field provides a range of affected product versions using different operators. Next, we will discuss the operation of the MyJVN Product Dictionary. In order to proposal of software product identification scheme, the MyJVN Product Dictionary plays a crucial role in facilitating collaboration between the vulnerability database and asset management system. Here's how the MyJVN Product Dictionary operates. A product not assigned PID case. The MyJVN Product Dictionary acts as a tag generator and registration site. A product assigned PID case, the MyJVN Product Dictionary served as a registration site. First case. In case of product not assigned PID, MyJVN Product Dictionary acts as a tag generator, registration, and dissemination site of the PID for the products. For products that does not have a product identification assigned yet, the MyJVN Product Dictionary generates and assigns a unique PID. This ensures all products, regardless of whether they already have a PID or not, can proprietary identify and managed. Also, MyJVN Product Dictionary may convert and generate CPE based on JVN PID. This allows for the easily integration and compatibility with an existing CPE system, enhancing the interoperability and effectiveness of vulnerability management practice. So next, in case of product assigned PID, MyJVN Product Dictionary serves as a registration site. For products that already have a PID assigned, MyJVN Product Dictionary allows the vendor and product owners to the register and asserting that the product with assigned PID. This registration process ensures the product and their corresponding PID and accurate documented and available for the collaboration with vulnerability database and asset management systems. Let's now discuss the description of MyJVN and MyJVN Product Dictionary. MyJVN is a platform that offers a range of sub-related vulnerability management of security information. One of the key components of MyJVN is MyJVN Product Dictionary, which serves an alternative to the CP database for the filtered security information tool. MyJVN Product Dictionary within MyJVN provides security information for the improved filtering. It offers enhanced and customized product identification scheme, allowing users to efficient filter and manage security information based on specific software products. By utilization, MyJVN Product Dictionary instead of the traditional CPDB, MyJVN enhanced CPDB. MyJVN enhances the accuracy and effectiveness of security information filtering, providing users with more tailored and relevant vulnerability information. MyJVN offers extended format of sticks and CSF to facilitate collaborating with the vulnerability database asset management system. STIX is a standardization language for the representing and sharing the cyber threat information and intelligence, while CSF provides a framework for the describing security advisory and vulnerabilities. MyJVN extends these formats by incorporating additional fields and attributes that are specifically designed to support collaboration between different stakeholders. Conclusion. We are currently reviewing a specification of MyJVN Product Dictionary and MyJVN for the MyJVN, and plan to develop in the 2023 with a trial operation starting in 2024. Our aim is to providing a solution hint for the global issue of software identification. We also look forward to your idea for the better collaboration. Thank you very much.
Thank you very much. Any questions? Yeah, please.
So if I understand it correctly, you only assign the MyJVN product IDs for products that are known vulnerable or that you release security advisories for?
I'm sorry.
If I understand it correctly, you only assign your IDs for products that are affected, known affected, or that you provide security advisories for. Is that correct?
One is specify the range of affected version using JVN PID. So other one is BEX-based, user BEX format in CSF. I think so. That is okay?
So my next question then would be, so you said you can assign JV and PIDs, but it still relies on human readable names, if I see that correctly.
So JVN PID is so authorizing and so unique in uniqueness, I think, global uniqueness. JVN PID is so assign controlled so JVN, then that so and just so global uniqueness.
But my question is, if you assign those, or a security researcher assign those after the schema, the question is, if they don't know what exactly the product name is, the vendor thinks the thing is named, then we run into the same problem that actually CPE has. So if you look up CPE identifiers for, say, and I'm from Germany, so I pick on German companies, from Siemens, there are a lot of CPE identifiers that are not nearly close what the product is actually called. How do you deal with that problem? Is there any way to retire JVN and PIDs?
Then, so we supported that so vendor PID. Then, if Siemens wants to own their assigned PID, we collected that information, set out the vendor PID, stored this entry, use this entry.
So you have actually a way to deprecate product ID entries.
This is this product dictionary is supported so JVN PID is a management ID. Each vendor wants that so I want that this package URL, CP, so software ID tag, SPDX ID, hash, acceptable, because then so vendor PID is so selective. Vendor wants us vendor selected. Is okay?
You can talk to him. Yeah. He's around after the session. You can have a bilateral discussion. Any questions from the audience? Okay. Thank you very much. Thank you.